All right, so in this video, I'm just going to talk about polynomials and then their x-intercepts. In other words, their zeros. And so I want to start with just the simplest type of polynomial, which is just a line, something like y equals x minus 3. And I want you to focus on where its y value is 0. Where does it touch the x-axis? And you can see it touches the x-axis right here at 3, 0. And that's because if you plug in x equals 3, right here to your equation, you'll get 3 minus 3, you'll get y equals 0. So that's why when you see the graph cross the x-axis, it's because that number, 3, makes the equation's y value equal 0. Let's try another one. Let's say we had y equals 5 minus x. Now 5 minus 5 is 0, so you see the graph crossing at 5. Let's do one more. Y equals x plus 2, or 2. Negative 2 plus 2 is 0, so it crosses the x-axis at negative 2, 0. Okay? So that's the simplest type of polynomial, are lines. They have a degree of 1. They have one x-intercept. The x-intercept is the number that makes it equal 0. Then you start getting into second-degree polynomials, where you have one factor multiplied by another factor. And you see here, I took the red and the blue lines and I multiplied them together and I made that parabola. What do they have in common? Well, the same places that the lines touch the x-axis are where the parabola touched the x-axis. So if you're able to solve the equation, and I'll just write it out, if you're able to solve the equation x minus 3, oops, come on, pen, x minus 3 equals 0, if you're able to solve that, then you're able to find the x-intercept of a parabola. The other equation was 5 minus x equals 0. If you're able to solve that, you can add x to both sides, for example. 5 equals x. That's where you find those x-intercepts. So if you have a polynomial where everything is in factored form, all the parentheses multiplied together, then you just need to solve each parenthesis separately. Okay? I can even bring in our third line, x plus 2, and you can see that now my polynomial is wiggling all over the place. Don't get distracted by all the wiggles that are happening. Just notice that the same 3 numbers that make those line equations equal 0 are the same 3 numbers that make my polynomial equal 0. Okay, so why does that happen? Like, why does my graph touch 0 at those points? I want you to think for a second, come up with any multiplication problem where the answer is 0. Without knowing what you came up with in your head, I can guarantee you one of the numbers in your problem was 0. You might have said 5 times 0, you might have said 0 times 0, you might have said 117 times 0, or 73 times 0. It doesn't matter what you said, I know that one of the numbers in your multiplication problem was 0. So when I have factors in parentheses, it's a big nasty multiplication problem. This purple polynomial is saying x minus 3 times 5 minus x times x plus 2. And so if I'm focused on the zeros, on the x-intercepts, all I need to think about is what makes them 0 one at a time. So what makes x plus 2 0? Negative 2 does. If I plug in negative 2 for x, this factor that I highlighted is 0. And 0 times anything else, doesn't matter how complicated, 0 times anything else is 0. So I know that if I see a factor of x plus 2, I know my graph will have an x-intercept of negative 2, 0. Sometimes people get thrown off if there's a factor of x on the end. What changed about the graph? When I threw a factor of x on the end, it added a 0 at 0. Why? If I plug in x equals 0, it makes this little part highlighted 0. If I plug in x equals 0, it doesn't make the rest of it 0. It makes it some other number. I don't even care what that number is, because if I plug in 0 right here, I'm going to have 0 times a bunch of other stuff. Okay? So because every multiplication problem that equals 0 must have a 0 in the multiplication problem. It must be 0 times something or something times 0. When we have a polynomial in factored form, to find the x-intercepts, we just think what makes each factor equal 0. All right, let me throw one more thing on here. Let's say I put a number in front of it like 3. Did that change where the zeros are? Nope. Make a negative 3, doesn't change where the zeros are. What if I make a bunch of numbers in front of it? Doesn't change where the zeros are. Because multiplying by a number that's not 0 doesn't change the fact that negative 2 will make this part 0. And 0 times anything else is going to be 0. Doesn't matter how many other numbers are in there. It doesn't change the fact that plugging in 0 right there makes 0 comma 0. One other thing, last thing, I promise. Let's say I put a squared on here. Did that change where the zeros are? No, they're in the exact same place. Let's say I put a cubed on here. Did that change where the zeros are? Nope. So it doesn't matter if I have numbers in front, called a leading term. It doesn't matter if my factors have powers on them. The zeros are what makes each of those factors, each of those parentheses, equal 0. All right, thanks for watching. Let me know if you got any questions.